Hi, in this video we will take a look how to play recorded samples using the Arduino Mega. We could also use the Arduino Uno or Nano, you can use them as well, but the Arduino Mega has a lot more memory. This especially has 256 kilobytes of memory that we can use to store samples in. So let's just take a look how we can achieve this. In the last video about the R2R resistor ladder we have already seen how to convert digital signals to analog sound already. This time we will take a step further, but we will keep the circuit simple. So let's take a look at the I/O pins of the Arduino Mega. It has really much digital I/O pins, but we need 8 pins that are mapping to one register here. So let's take a look at the sheet here and the mappings. So we have several possibilities here. This K port is mapping to the analog ones. Then we have the A port, which is mapping to 22 until 29. And then we have C, which is reversed mapped to 30 to 37. I will pick the C port to connect the converter. So we take this breadboard and our R2R resistor ladder here that we have prepared already, and we can just plug it in, then connect the ground first here, and we might need also some power from here. So we have ground over here. And we have 5 volts here. We take this and connect this to the breadboard, so we can use the ATMega to power our circuit. And now we have to connect just the lower significant bit to 37. So this is 37 here, and then just so on. Okay, now we need some amplification. We want to connect to this box here. It has 4 ohms, but I don't care. We will just connect it straight without any resistors. This is quite dangerous since you can blow up your transistors, but I will do it anyway, just for fun. So I will take this BC547 NPN transistor. This amplifies the current, so we get some distortions there, but it's a really simple circuit, so I will just use this time. So we connect the output to the base, and then we connect collector to 5 volts. And then usually we would take the emitter and connect it directly to the box, but we want to have more loudness this time. So last time we used a smaller speaker and just this amplifier. It was quite silent, and we want to make something like a Darlington transistor. So we want to connect another transistor in series. So I take this thick one. It even didn't fit to the breadboard, so I just saw that some thinner wires. I got this transistor from an old TV. It's rated for several watts and thousands of maybe 600 volts, etc. It's a really huge one. I have tried to use another NPN 547, but this is getting quite hot and this might blow up. So I will just take this thick one here. It has a slightly different connection. I think this is base. This is the collector and this would be the emitter here. Now we can connect the box. Okay, so we take two wires here. This one will be connected to ground. I can just connect this right away. And this one to the emitter. Okay, now we are finished with our circuit. We have the box here. We have a Darlington Transistor-like construction here. It also works with one, yeah, but it's not loud enough, for my opinion. And we have the R2R resistor ladder, which is connected to the C port. We have power here, and that's all. Now we have just to connect this and program it. So let's check it out. Now we need some samples to play. I'm using Audacity here. It's free, you can download it from the webs. You can record something yourself or just rework existing audio files. I have prepared this sample here. We don't have much memory on the microcontroller, so we have to take care that our samples are not too long. This sample is about 1.7 seconds. At the 44 kHz sampling rate, which you can see here, this would be already 74 kilobytes. Since the arrays are limited to about 32,000 elements for the Arduino compiler, we have to cut in the sampling rate here. So we just take 16 kHz. This is enough quality for our application. So next step is to convert it to a raw file. So we can just use this export here to export a raw file. We choose another uncompressed files and set header raw, headerless, and unsigned 8-bit. This is really important since we want just 8-bit per samples. We click OK and store it as sample raw. And this can be ignored here. And that's done so far. Next thing that we will need is a binary to header converter. This can be downloaded from Google Code. It can be used to convert this raw file to a header file like this. And that's all. So first of all we create a new sketch. I called it sampling. Then we have to set programmer is Arduino, it's okay. Then serial port is also okay. And the mega with my chipset, so it's the 256 kilobyte ATMega here. This is okay. Then we have to set it up. So we just type right setup and set with a crude method the DDRC2255, which sets all the bits of port C to output, and then we just copy the contents of the header file that we created. We just need to copy the data here, so I copy the complete array and paste it. I will just paste it above. Okay. And then we have to tell the compiler that we want to store it in the program memory. This is a quite important step. So we have just to type here program memory. Usually we had to include a file for this, but using the Arduino everything is set up there. So this is stored in program memory. And then we have set up the port, so let's play the sample to the port using the loop. and we just write to port C, and we want the contents of data at position I, and we want to increment I afterwards, and we need to define I outside of this loop. So we take a short here, and then we have to stop playing or just repeat the sample when we have finished playing here. So we want to check if I is bigger or equal than data size of data. Since we are zero based, we have to also bigger equal check here. And then we want to set I to 0 here. Accessing the program memory isn't straightforward. You will have problems there since it's segmented and so on. We're using 8-bit processor here, so we have to use a function for this, or this is some kind of built-in function of the compiler. So we want read byte, but we can't give it the actual data, but we need to give it as parameter a pointer to the actual data. So I'll just make it like this. Since we want to play at precise 16 kilohertz frequency, we have to add a delay here. So we want to delay in microseconds. We need the microseconds, so 16 kilohertz. We get 62.5, so we just take 62, doesn't really matter, you won't notice a difference here. So we just delay everything by 62, and now we should have a result here.
Yoo-hoo! It works! 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 Yoo-hoo!